I'll focus the two renewable energy technologies. One is the wind and other is the solar. Why the forecasting? I want to just say ANN, as we all know, it is an artificial neural network. This is one of the digital technology, and it is a successfully employed in the power system from the long back. As we know, this is a tool for the forecasting. It was used for the weather forecasting very in the beginning, but now we are also going to forecast the renewable power, because we can very exactly forecast, then we can manage our power system in a very efficient way. Why the forecasting is needed? You know, our whole power system plan, when the power system was growing, and it was, when the first power system came in 1882 in the Powell Street of New York City, it was basically having a few loads, cable was interconnection, and then DC generator of 110 volts were there. So the power system means it is normally there is a misconception of the student, because most of our curriculum says the transmission systems, generation system we talk, and also the power system studies and all the things in power system operation and control, all these are related to the EHV system. But the full power system is that which includes all the three big giant sectors: generation, transmission, the distribution, all these three are there. In this, what happens, the load is a full control of end users. End users, maybe it is just like our customers. So whenever we turn it on our demand, the generation must be balanced by that. So always we say the total generation should be equal to the total load plus losses. Once I'm changing my load, the loss will also change, and thereby I have to change the generation. If you are not changing the generation, you know what happens. It is the frequency will change, and the frequency may rise, may fall, and our grid may fail, and it may not operate successfully. So what we do, if we can forecast the load, then we can have the proper, although the load generation balance or load generation frequency control is automatic. So the generation will be taken care. At load is increased, generation will be increased. Load is decreased, generation will be decreased. Okay. So that is that. But for example, let's suppose you are having only 5 generators turn on at a time, and our demand is actually more than the 7 generators. So turning out a generator in a fraction of minutes or hours is impossible. We require minimum 2 hours to 4 hours for if the generator is running. Then it will generate the power. And if it is in a cold state mode, then it's 7 to 8 hours. So it is a better if I can know that what will be my load after an hour or maybe half an hour, so I can plan my generator to be active so that I can maintain the continuity of the supply. So that's why the load forecasting was done when the power system was growing. And it was very, very old. As I said, it is 1882 when the first power system came into the existence by Thomas Alva Edison. It was the load forecasting we were doing, and we were very accurately, because it has a very set pattern. You know, what is the pattern of the academic institution's load? We know the office is opening at 9 o'clock. It is closing at 6 or 5 o'clock. The load will be rising and it is going down. We know in the evening, all the domestic consumers are returning to the peak will be done. So there is some variation, and that we know. But exact value we want, and that is done. But later we adjust our power system is a change in the different concept. That is, we started the market, means now the electricity is traded. So I have to know what is the price at this hour, what is the price after 2 hours. Why this is required? Because then I can make my optimal utilization of energy. Right now, no doubt, being an end users, we don't bother. The price is same throughout the 24 hours unless until government of state are changing. But in other words, here even our state government, which is also buying power, every 15 minutes the price is changing of electricity. So now the price forecast has become one of the options that we have to forecast so that I can shift some of my load at when the price is less. So the price forecasting is started. Now due to the burning more and more coal and fossil fuels like diesel, lignite, and all the things we were doing, now the people started talking about the renewable power, because we are having the limited resources which can generate, and there is a depleting. As you know, right now we are buying the coal from South Africa and the Indonesia and Australian coals we are buying from India. Earlier we had the coal mechanism because most of the power plants are very near to the coal pits, and the coal yards were allotted to that. But recently, the new coal is in the NCL, we say, the new coal policy came, and based on that, it was said, look, there is no quota for any power plants. You have to buy the coal from anywhere in India, anywhere outside the world, and you have to generate. So we are buying coal from the other countries as well. And normally we are trying, why not then we can go to the near to the sea area where the coal can be easily come. So the depleting and the poor quality of coal in India is one of the big problem and big challenge. And then the people start thinking, why not we can go for the renewable power? Not in our country, it's all over the world, the renewable power, and especially the focus are to the wind and the solar. And the wind is also very old. Wind was used for even though for the pumping, irrigation, etc., taking water here and there. Later, it is started with electricity generation, but still people were not very convinced. But the once technology increased, and especially the invention of the power electronics devices, because earlier we were using induction generator for the wind power generation. Then the later we went for the DFIG when the power electronics came into the picture. Now we are going for the permanent magnet synchronous generators, especially for the wind generation, because variable speed is one of the concern in the wind turbine. You'll see always the wind turbine now is rotating the same speed, whatever the wind speed is there. So the rotor speed is same. Earlier, since wind is more, so it was rotating more, and then the frequency was changing. So a lot of things were there when the induction generators problems were there. So now if you can forecast properly the wind power, that is also useful for the grid operators. And that's why the forecasting is a very, very challenge. And you know, the forecasting of the two things are very, very difficult, especially forecasting the behavior of person and forecasting the nature. These are two of the very, very, we can forecast the machine, we can forecast other things, but the forecasting of these tools are very, very challenging. And if I think forecasting of the nature is easier than forecasting a person. What he's thinking, what he's doing, what is inside, it's totally different. As you can guess what you represent yourself. And the forecasting is also very attractive one. Whenever we face the problem, we go to the person to show our hand, even though sometimes we go with the kundali and we say, Panditji, see what is my problem here. So the forecasting, even the elections, the elections on the exit polls, both are different. Exit polls and forecasting are different. Forecastings are done before, and based on certain data they are doing and forecasting it to be there. Now the exit polls are there because they get the feedback of samples they collect. Based on that, they might interpolate and then give the data. And you see, if the exit polls are coming, everyone is watching the TV. Oh, what is going to happen in the election? So these terms are very, very touchy, very, very touchy to individual. And that's why the forecasting is also one of the parameters which you use. So in the power system, load was the beginning. We started with the market where the price forecasting and ancillary services forecasting, the renewable energy forecasting, all these forecastings are playing. Now we had the classical techniques, those were a lot of problems. So then we people started using the artificial intelligence or soft computing, or you can say intelligent system application for that here. So I'll be talking this ANN based forecasting, which we did somewhat at IIT Kanpur, which I'll be showing. So can move. So already which I talked, it's very well, it is, you can see all the things I discussed, why it is more important in the recent few years, decades, I can say, and it is a fast development and deployment of renewable energy sources, continuous energy demand because increasing. This is the fast depletion on the prices increase of the fossil fuels, limitations of earth fuel resources, environmental degradation and the protection issue, emergence of electricity market. So these are the another things which is happening, and so the various type of renewable energy sources, wind and solar photovoltaic are two are major, but we are also having the fuel cells, micro turbines, we are having biogas, cogenerations, many small tidal, all the things what we are thinking they are coming, but the majority is the wind and the solar. Go ahead. Okay. So the various challenges already I was talking in the beginning. This you can say the output of these renewable energy sources is highly intermittent in nature because they are dependent on the nature. Nature, you can say, if the suppose that the solar is there, if the cloud is coming on that, you can say certainly its output will be changed. It is certainly after maybe 15 minutes or 20 minutes, you find there is a cloudy or it's going to rain, output will be changed. So it is very highly intermittent in nature. And that's why it is not fully controllable. Why I'm taking not fully controllable fully, because you can make it zero, because you can turn it off. But if suppose I want there is a 1 megawatt here, we say the PV, I want 1 megawatt at any time of the time. It is not possible because you require the sun at that time, and that solar irradiance is required. Making zero is possible because just turn it off, switch it off. But increasing upward, it is not in our hand, and it is depends on the nature or availability of that energy. So this is a very much challenging in the grid operation. That's why we require a solution for this. If we can have the accurate forecasting properly, we can very easily manage our the solar power along with the existing my other resources like hydro, major hydro I'm talking, larger hydro, thermal, coal, gas, in thermal coal gas, all the things are coming, even the nuclear as well. Those can be combined and we can operate properly. Other problems, just we know, is mostly dependent on the weather, already I said, and they are exposed to atmosphere. If they are exposed to atmosphere, it's cleanliness, means more maintenance issues are there. If it is mostly on the weather, so sometimes it's raining, sometimes temperature is very high, temperature is low. So a lot of problems and the cost is involved in the maintenance, these units. And because we cannot put inside the cover like the thermal power station, the generators, turbines are inside the cover. Only the coal, basically, it is on the outside. But here, everything is outside. And that's require a lot of things and maintenance issue and more maintenance cost. Another, already I talked, it has a low inertia because the solar, there's no kinetic energy can be stored. Only you can store in terms of battery. You can store, but in terms of device itself, you cannot. The solar cannot store by itself. It can have a battery connected with it. The wind, it has some rotating mass. But if you are having the full converter you are using, then it is gone. If you are having something like a DFIG or induction generator type of wind turbines, you can have, but very little. So why it is required? Because load is so erratic change that frequency variation will be more. So then we have to have some sort of inertia also in the system, because slowly and slowly we are going on the renewable and more penetration is coming of the renewable energy sources, and we are giving away with our conventional sources, which were the more inertia, big turbine, big your synchronous generators. Those are having huge kinetic energy, and those grid is very large. You are having large inertia, and large inertia means frequency exertion is very small, and you are having the wind. You are not managing properly, the frequency variation will be very high. That's why people are saying, why to go for the AC grid, go for the DC grid then. And that's another solution. But can we change all our operators? Then if you are going for the new one, then people are talking, if you are going for microgrid, why not the DC grid? Many people are advocating for go for the DC grid rather than AC grid at the utilization level where the renewable energy penetration is more. So you can have the AC, convert it DC, and have complete DC power supply. Because now you can see when we were, I talked in early, only the AC generation was there, AC transmission was there, AC utilization was there. Utilization was your light and fan and your induction machines. So that was perfectly AC. Generation was synchronous machines, perfectly AC. Transmission system was the AC transmission system. But now you can say everywhere the DC now. First we started with transmission system. When this Mercury arc valves were there, then we started HVDC transmission system. We started adding in AC system the DC system for the transmission system. When the power electronics came, again this gave a lot of momentum to the HVDC. Then we had a lot of, even our country, the huge number of HVDC lines are there. The lines, you can say Anpara-Riyand line, Riyand-Dadri line. We are having one big transmission line that is coming from Bishwanath to Alipurdar to the Agra, which is coming here. There is a plus minus 800 kV transmission system. Means line to line voltage is 1600 kilovolts. And that line is approximately 1800 to 1900 kilometers. That is coming from your Assam, coming to the one terminal we are tapping at the West Bengal, that is Alipurdar, and then it is coming to Agra. So these are the major ones. Then we are having many in the NCR region, like outside we are having the circuits of the DC. So the DC now we are using too much, and now the fax devices, again with help of power electronics, different devices we are using again to improve our transmission system, to improve the stability, to improve everything that we want the generation can reach to the end user. Now then we started using the DC power, because your mobile, your computers, your laptops, your battery chargers, all this your DC. Now we are talking about the DC, your washing machine, inverter based DC, that is coming. Now people are talking the DC based, even though air conditioners. So many devices, many loads are now going to be DC. So if it is a DC, why not we can have our DC supply. And more precisely, you can say nowadays in the house, it is a 220 volt supply is there, 220, 230, whatever you can say. That is another more debate is required. So the 220 volt which you are having, but now your charger is having a different voltage. So what we use a charger. It is a 6 volt, 9 volt, 12 volts, various chargers are there. So why these chargers are also lossy? So it is a possibility by having the DC. You can have the power supply of the different voltage in your house without chargers. Simply you connect and you can get it. People are talking about the wireless charging. So many things are coming up with basically the. So the AC side, as you can say, when we had only our loads, that is about the AC load, this motors is induction of single phase. Now people are talking about the BLDC. Brushless DC motors are coming. So we are basically adding more and more DC loads. Now the transmission is AC-DC and the load is AC-DC. Now coming generation side, as I say, 3 sets. In that you can find that your generation was earlier synchronous machines, and synchronous machine is the fixed frequency. Now we are adding more and more wind and the solar. The solar you are adding is a DC power. You are adding your wind. If you are having permanent magnet type of the wind turbine, it is a DC power, because AC is converted with a converter circuit. Fuel cells is a DC power generation. Battery is a DC power. So now you can say we are adding more DC in the generation side, so that we are having the mixture of AC, DC at each level. And the DC is increasing its capacity. And we are saying the 5% wind, renewable, 10% we were saying in the beginning, 20% say, now we are saying 30%, 50%, and people are saying why not 100%? If it is 100%, so then inertia is one of the big challenge. Even though in 20-30% also the inertia is a challenge. Another, we are using the power electronics that is basically used. And the once you are using the power electronics, because these devices cannot be implemented unless we are connecting with the power electronics. Power electronics means it may be converter, it may be what any type of the DC to DC converter or DC to AC converter or AC to DC converters. The converters you are using, and then the question of the power quality is another thing. And another is a control during the disturbance. That is also because many end users are connected. Everyone is switching in and out. What will happen to these renewable energy sources if the grid fails? So even though sun is there, it can generate, but it's not generating because grid fails where it will inject the power. So all the things are there, the control mechanism. So we should have the local storage, and it can be connected locally when the grid take up, and then we can generate as well. Now already Prof. Saxena told, there's no doubt you have the load, and there is a power shut off from the city side or maybe from your grid, power is zero, and you have generated, you casted your battery also, and now the supply has come. So at the same time, no doubt all the load you have switched on, and your battery is also switched on, so huge load. And once your load is increasing beyond than your connected load, huge penalty will be charged by the electricity board, and that is another. So the good control mechanism is required so that we should keep up, so that we should not be penalty. Many times I've seen people run their DGs to minimize that capacity cap which is we are paying to the electricity grid. It happens many times. So a lot of technicality I'm not going, it is basically related to the commercial aspect, how to handle. So that is the control mechanism is also there. And since small things are used, so there is a reliability is another concern, because you are adding power converter, you are using small wind turbine, small solar. Sometimes you say one panel is off, and then it is output is not there. There's a lot of unbalancing is there. Suppose you are having the single phase, normally we are having in our houses, these panels are single phase. Load is there, power supply is a single phase. So many one is connecting the different capacity in the grid, so that your unbalance is another concern. And unbalancing, you know, that creates many problems in the power system. So these are the various challenges, but it is not that we are moving away from the renewable. We are going for the renewable energy sources, and we are working very hard. Technologies are there, and still the technology are every time we are improving our own technologies, and we are making our system better and better. We are trying to have more green power. Go ahead. So another changes are happening along with the renewable side. That's the technological changes. Normally we say the digital energy transformer. No doubt we require the energy, and energy we require in the perfect sinusoidal way, because earlier it was generating sinusoid. Due to the power electronics, now it is not sinusoid. Just measure anywhere in the just near to your computer center or maybe anywhere in the campus, you will never find it is a sinusoid. So it is a distorted because more and more DC components are putting in the system, because we are not using the very high quality converters. we are using very small, even the poor quality of the charger, even they are deteriorating. So the digital technology, basically emergence of one thing, we want the digital technology which can transform the energy, green power, and many, many more. That one emergence of digital technology, plus the Internet of Things, artificial intelligence, machine learning, computing also we require, and the blockchain. Many, many new technologies are coming for the application of the optimization, for the forecasting, for estimation, for even though identification for the control purpose, many things are rising, and that we are going to use this digital technology in our power system, and we are using from the very beginning. Another, the arrival of the increasingly affordable distributed powers technologies, with better operation and control. Now it is feasible. Small, wherever it is there, we are connecting to the grid. And that is basically one thing which is happening, and we are having the good operation and control mechanism. And another, we want the decarbonization through the renewable energy sources. That is a motive. And all over the world, people are going for the renewable energy sources. And one type generation, we also want that we can use some technology that is the energy efficiency options. Because your motor which you are using may be not efficient. Your air con may be not very efficient. So if you are saving even the 1 kilowatt power at the load end, means generation is more than 1 kilowatt you are saving. So that basically because there is a losses in the system. So that is also, and we say it is a low carbon technologies are also. So both side generation is renewable. Second, load side, we have to go for the energy efficiency, efficient devices, so that we can again save our the fossil fuel and make our green or carbon neutral technology. Yeah. So these three can be described in very well. It is a go one more. How about? So it you can say 3D normally we say. 3D, now the printers are available. Similarly, I said the 3D thinking is required. So you have to go for the digitization. And digitization is nothing but the adaptation of intelligence techniques, especially for optimization, for the control applications, for forecasting. You can apply all the digitization, and that is digital techniques which I'm going to talk just like your AI or AN application for the forecasting. Another is we are going for the low carbon technologies such as wind and solar, renewable energy sources. Already I talked about the challenges, and that's why we have to, but we have to go for this, and it is happening. And second, we have to go for the wherever the small generation is there, we have to tap it so that it can minimize your T&D requirement, transmission distribution network requirement. It can improve the reliability of the system so that even though grid fails or something happens, a line which is coming from the remotely placed in your village, if you are having the solar and wind, you can basically provide the emergency loads. Right? So few things we know: the digital data and its analytics can reduce the power system cost, leading to the less electricity price to the end users at least 4 ways. That it will reduce the reducing the operational and maintenance cost. If we can use the digital techniques, it improve the power plants and the network efficiency, reducing the unplanned outages and the downtime, extremely organize the lifetime of the assets. We can go for them, the health monitoring of the operator. Many a times we found the transformer is burned. This is a very common phenomenon in the power grid, especially distribution system. You can say transformer put there. So it is a why we are not monitoring the health of the operators. The health monitoring is other thing, because what we do, a person we know it is a sick or old, always we go to the test our blood, test our BP, test our sugar, test our the heart. It is we do, but we never do for any equipment unless until it is a fail, but completely or burned properly. So the now people are talking about the health monitoring, and then it is very easy with the help of signal processing techniques that we can monitor the health of the devices, and so that we can improve its lifetime and we can improve the operation and the continuity of the supply. So the greatest transformation potential for the digitization is the ability to break the boundaries between the energy sectors, increasing flexibility. We talk the resilience grid, we talk the flexible grids. So all these things, if you are using this digital technology, that is, you can possible, our grid can be flexible, not rigid and tight. And where means all the renewable power which is changing, load is changing, everything is different, and everyone is adding, injecting, withdrawing power. So that complexity can be minimized with the digital technologies. So various already I talked that we can have the smart grid where you can have the demand response. End user can also support the grid. Suppose there is a shortage of power, you can sell to the grid, especially now the electric vehicles. Electric vehicles, now it is thought that it is just like you are coming and driving it from your home to office, park in the grid, park in the parking lot and connect and have a device When it will forecast the price, it can charge when the price is less, and it can discharge when the price is high. And you will find at the end of the day, while going back, you can have certain bucks of money. You can buy vegetables and fruits for your family member, so that you can make a lot of money with that one. So that is even though that concept is coming, it can be done so that you can have the demand response, means your price can be up and down, and you can use accordingly. Means you can sell your power, you can consume power if you are having battery storage. So many things are happening across the globe, and a lot of people are working. So that's why this electrical engineering, which we are studying in the long back, core machines, generation, transmit, and distribution. Now it is not left with that. Now we moved ahead. The technology is changing already. Yeah. Go ahead. Now coming to the basic, I put the background and the basic things. Now I'm going for, it is the forecasting. What is the definition? The forecasting is a problem of determining the future value of a time series of current and the past value. You can see what happens. This is a black line you can see here. So here is so bad. Expired. Expired. So you can see this is a line. If you see from this side, I can say, you can say the left hand side, the various dots are there. These are the measurements. Measurements, we are having the data. For example, I want to forecast. Right now, I know what is my temperature. Just simply one thing, forecasting a temperature. I can measure it. I want to know what will be the temperature after 1 hour. So I have the temperature at this moment. I have the temperature even the previous years also, previous hours also. So based on that, can we get the temperature very accurately after 1 hour or after many hours? So that is known as the forecasted value. Means knowing the knowledge right now and the past knowledge, I have to know what will be the future value. So that's why it is a one-time step. Means I can have one step, means 1 hour ahead. Once I have reached 1 hour, then again next hour, or from here itself, I can forecast for the 24 hours, many steps. So based on that, it is a classified 1 step, 2 step, or maybe multiple steps ahead forecasting are that. So that it can be very short forecasting, maybe for a few hours. It can be for a few days. It can be for 24 hours. It can be for a few months. It can be for a few years forecasting. I know, suppose I know what is the load forecasting, what will be the load in this Agra city after 5 years? That is a big challenge. Why it is required? Because then I can plan that what will be the requirement of transformers, what will be requirement of the cabling, what will be requirement of generating power stations if required. All the things are required to the plan. So that is required for the planning purpose. Very short and short we require for the operation purpose, because quickly I have to deliver. We cannot have a time that we can plan and we can dig the roads and then we can put the cables, etc. So the some are the basically very short, medium, and the So the long term, that all the things are there, and that the forecast. So it is a load is one, but for any things you can for forecasting or temperature. What will be temperature after 5 years at the same date, same time? That is now question. Why to know? Always we try to know, because that relates many things. So go ahead. So this is a basic definition, knowing the past data and the current data and the future data. I have to forecast it, get it knowledge, and that is known as the forecasting. Move ahead. Yeah, one more. Yeah. So the before the deregulation means competitive power market, only the load forecasting, I'd say the beginning only we were doing the load forecasting, and that was used for the economic operation and the unit commitment. And also that was used for the maintenance and the planning purpose. So maintenance is a short term, planning is for long term, and economic operation for the very short and the short term. These 4 types of the forecasting is done for the 2 purposes. But now I said that it was the load forecasting, and we require the price forecast, ancillary service forecasted, and also I talked the renewable energy power forecast. That is a wind forecast and the solar forecast we also require. Yeah. So that I will be talking about the wind forecast and the solar power forecasting. Go ahead. Yeah. So move. Yeah. So already in the system operator's point of view, I said the planning problem. So due to the uncertainty, unlike the conventional generators and the power generations cannot be included into the economic load dispatch and the unit commitment problem, operational problem. And the wind power producer should also know One is the wind power. Why need is the operator is required to know. Second, even though if I'm at the wind power, I should also know what will be my output after 1 hour, after 1 day, so that I can get maximize my income. And that is happening because nowadays, as you know, this wind power, they are selling their power at the variable rates. We are having the stock exchange where the wind power capacity is sold because they are not even generating their capacity, how much megawatt they are having, based on that they are getting money. This one, that is called wind power certificates or solar power certificates. And second, if you are generating the power, for that they are also getting. So it is the government making a policy that we should subsidize and we can try to make the wind power and solar power effective so that people can buy. And that's why the wind power forecasting or solar power forecasting is not only the system operator, but also for the wind owners, they should also know so that they can maximize their, sometimes they are bidding in the market, so the penalty is their imbalance cost, etc. So go ahead. So already you can say the three categories which I told that it is you can find is the very short-term forecasting, short-term and the medium-term forecasting. You can say the 2 to 3 hours is known as the very short-term, is up to 24 hours. It is short-term. If it is going to be the after the, you can say one day to even the 1 week, it is going to be medium. And the application, you can say the various applications why these forecastings are done. I'll leave this PowerPoint here so that you can read. So these are the various things for those forecasting horizon. It is the various purposes we are using in the power system management. And these are the very, very important tools. Normally they are the, otherwise our grid cannot operate very successfully. You can move. Yeah, right. Go ahead. Yeah. Yeah. So you see the wind power. You see, I'll show you. So if we know if the wind is speed, wind is blowing, only the wind power output will be there. No doubt if the wind speed is zero, output is zero. Very obvious. But it is not necessary the wind speed is there, but wind power is there. It can be also zero because it depends upon many, many other factors as well. Now the direction is changed. For example, your wind turbine is standing here and the wind is coming here, it will be giving maximum. But if wind is coming from this direction, it's gone. So the wind power is no doubt the first criteria for the wind power output. Wind speed should be there. Means there is the wind should blow. But these are like wind direction, wind turbine layouts, because many wind farms are there. And also it is a terrain. For example, if you are having the hill and there is a foothill, where is your wind turbine is there? It may be flowing the top, bottom, all the directions. So these are the various other parameters are there which will be deciding your output. That's why its forecasting is needed. Otherwise, if these factors are not there, I know this speed is this, output will be there. What is need of forecasting? But affecting these one, I'll show that you can see how it is important. Go on the next slide. You see, this is a first one is the wind speed. It looks a very hazy data, although it is for the many hours, 2,000 such samples. And you can say the wind power output also shown is the red. Now, if I draw on the same scale, wind output versus wind speed, go on the next slide, then you will find this is the scenario. Now you can see this is a vertical line why I'm showing. For certain, you can say the wind speed of maybe it is 8 or 9 meter per second. There is a two outputs on the power output. You can say it can be 80 or it can be approximately 120 or so. So what will be output? If it is a straight line, there's no question of forecasting. Then we can know the measure of our wind speed, output will be known. But since you can say the how come it is a variation is there, so in this range, what will be actually at that time? That's why the forecasting is needed. And if this is a very wide, if it is a very thin means one line, if it's a wide, then it is a more error will be there. So that is basically due to this forecasting is needed. And you can say the wind speed at any station it is taken. So this curve is normally followed. Now you can say when the wind speed is higher, output is saturated. It is not going a linear one. Also, you can say wind speed is less, the power output is zero. So there is a cut in speed, there is a cut out speed. So the wind speed is very low, output will be zero. Wind speed is very high, output will be zero. So only in between the wind power output will be there, and that we have to forecast, and that is a challenge in this to get it. Go ahead. So the various forecasting approaches we were using in the they are the mathematics. They are the statistical. They are known as the linear regression models. Those were used, and the forecasting value are linearly dependent on the past historic data. So the past data already I said we are having. Based on that, we can have some equations, some interpolations, and based on that we can say. So the various models are there. I'm not going to talk much details like autoregressive, moving average, ARIMA model. Many models are there, and it is based on the mathematics that is basically done. Go ahead. So there is another even the variation. So always people are doing, these are the conventional methods. I'm not going to talk the conventional methods. They are having its own limitations. Go ahead. I'll show the various limitations of these models. Go ahead. Yeah. So the limitations of the linear regression models are that they are a linear model. They cannot capture the nonlinear relationship between the independent and dependent variables. The forecasting error increases rapidly with the increase in the look ahead time. For example, if I'm forecasting right now for after 1 ahead, suppose I want to know whether it is a sunny day, it will be sunny after 1 hour or not. So it is very easily I can forecast. But whether I can forecast after 5 hours, whether it will be sunny, it will be very erroneous because it's a nature dependent. So that's if you're moving ahead the longer duration, the error will be increasing in your forecasting as well. So the model parameter have to be updated very frequently. Every time it's 1 hour ahead, then we have to update it. That's why you remember when the beginning, once we say we are having the supercomputers, because earlier the computers were very low speed. So any high end computational device were known as the supercomputers. Right now, we are not talking the supercomputer. We are saying HPC, high performance computing. So this HPC, why we require the huge data we are having. Huge data once you are having, then which data you have to select to forecast that one. And always you have to update it. That's why nowadays, I do remember when we were like you, then we were on the radio, radio was the only device where we were listening, okay, forecast, whether today it will rain or not, or they were saying it will rain today. And I'm sure on that day it was not raining. But now they will say it will rain today, certainly it will rain. So how much forecast? They'll say, 2 दिन बाद पानी बरसेगा, it will rain. Forecasting could say how accurately people have moved. This is the technology and high performance computing. And that is basically use of the digital technologies are basically making it true. And that's why also we are doing it. Another question arises. For example, here suppose right now, I know the temperature. Yeah, we know the temperature right now and measure it. I want to know the after 1 hour, the temperature, what will be there. How to, you can say this hour information is very useful after 1 hour. 1 hour, maybe previous data can be also giving some direction. But it is also possible that 1 week before the same time data, what was there. So that's those parameters, which parameter I have to pick up so that my computation will be fast. Otherwise, we are having millions of data for knowing what will be my temperature after 1 hour. So that is another, we say, correlation factors and cross correlation factors. Which parameters are going to affect, which are basically identification which are going to do. These are the very important to forecast it. So that is another statistical way to the input selection, that which date, which time data is going to affect much to know this based on my previous information, and that can be used. So that's the forecasting. Go ahead. So this basically the nonlinear regression model is a neural network model, and various variety of neural network models are there: feed-forward neural network, radial basis neural network, recurrent neural networks, wavelet neural networks. All these things are there, and also using the tuning of those parameters, because we are updating all the time. Once error is there, we are keep on training these algorithms by using genetic algorithm, particle swarm optimization. These are the evolution-based optimization. These are also digital technologies. So they are basically used for basically knowing my forecast, and they are giving the very exact and very good information. Right? So other methods are also there, like fuzzy, adaptive neurophagy. Various people keep on trying the different, and people are trying to improve so that we can improve the accuracy. If the more accurate is there, we are very happy. And nowadays our forecasts are very accurate because having the good computational tool and the good technologies and approaches, and that is basically done. Go ahead. Now you can see now coming to the actual topic, our wind power forecast. One thing is that's here I am having whether I should forecast my wind speed or wind power. Two things I can forecast. Right now, I can measure my wind speed, and I want to know after 1 hour, my wind turbine, which is running, what will be the power output. So one is that we can forecast my wind speed at that time, and based on that, I can get it. So that you can see that wind speed, I can measure this side, and there is a curve given by this manufacturer's curve, which is given, and based on that, I can find what will be my output. But there is a lot of problem directly. It is not related. Already I showed the first figure. It is a lot of variations in that, so that it is a better. I can forecast wind speed also. I can forecast wind power also, and I can have the certain mixture here. Then I can give best wind power, because my final, as an electrical engineer, I am not worrying about the wind speed. I am worrying that my wind turbine is there, how much output it's going to give. So, but this wind power output depends upon the wind speed. So the wind speed and wind output, they are related to each other, but how much it is related, again, it depends upon the forecasting approaches. Go ahead. So the various numerical weather forecasts are there. So physical models are there. And also it is very important, you can say my wind turbine is maybe the 80 meters away or maybe 100 meters away. So the wind speed, if you are forecasting here at the ground level, that may not be at that level. So we require the wind speed at the hub level, where it is your shaft is there. So that wind speed I require. So the wind, once you are forecasting, then at where you are measuring, and then we have to again interpolate, and then we can go for the wind power forecast. But nowadays, the new models we are using, the model 2, where we are having the wind speed and the wind power forecast, and then having some statistical model, then we can get the wind power output. So the wind power also, I have the data, the previous data, which is already existing. Wind speed is also there. Using those, I can get the wind power. And the various statistical models are fuzzy, NFIS, neural network, ARMA, and yeah, all the things are there which we can use. So go ahead. So what we did, we found that we can directly measuring the wind power, it is not giving the good result. We directly measuring the wind speed and then converting, it was not giving. So we proposed the two-stage model. What we did, first we forecasted the speed also at that time, and that forecasted maybe after 1 hour I'm talking. Right now I'm doing here for the next 1 hour. So what I did, I forecasted the speed also. I forecasted that, and actual here, you can say the wind speed forecast and actual at this time, and the forecasting at that time. Using that and the power, the past data, I forecasted wind power. So the two models were used, that is the adaptive wavelet neural network and this feed-forward neural network. What is the difference between the neural network? Go ahead. You can see in this data, we took certain portion of the data because the time series data. I have taken the data, we have to train it, just in large present. You'll see how the data is moving. Yeah, you can see that is a very compressed. This is a variation. You can find it is a very difficult. You can see the wind, how it is flowing. It has no correlation. It is not very, you can say it is a daytime, nighttime. It is very, very difficult to do. As you know, nature, the wind, flow, directions, all the things are changing. Go ahead. So that portion I can do. Yeah. So these are the various study that we can take, which data I have to take for my actual output. Past data I am analyzing. Based on the past information, I can do all the analysis. I can say this hour, if I want to forecast, which are the data points are important to me. Because I can say the millions of data are there. The million trillions of data are the past, which is available with me. I have measured this. So which one is the best, which I have to choose, and then I have to apply in my neural network. Go ahead. So that's the autocorrelation, and this I did. You can say how much error we are getting. Huge error, you can say it is the wind speed. Here I forecasted only wind speed. You can say this actual is applied. And the forecasting AWNN, you can say red, the peak is covering, but you can say FNN is not giving, a lot of errors are there. So that error is not justifiable. Go ahead. So we changed it, and our model, what we did, that series which I showed beginning, I broke into the various components. How we did? I have basically divided with the filter. Means the last row, you can say this is the wind data. what I did, I have to provide the filter. There's this signal in the different frequency domain it is done. So it is from the details to the approximate analysis. So this is a different frequency band. This is having some frequency, and that is broken. And for each frequency component, I put one neural network, and that basically giving the best data. And that is on. Go ahead. So you can see what we did. We first, this your input is X. What I'm doing, this X is divided into 50, higher frequency and lower frequency. So D1 and the C1. Then C1 is again divided into two, D2 and C2, half. Then so on. So it is basically, and for each component, I'm using one neural network, and then later I'm adding, because my X is 1, and then my X tau, which I'm measuring of the next hour, that is the estimated value, which is I'm going. So that is a resolution analysis, which using the wavelet transform, it is used, and then it is basically giving the very accurate result. Go ahead. So this is the analysis we did, the ACF, to decide the inputs. Go ahead. You can see from this table, you can know this how, because this figure is very difficult to explain. Go ahead. Yeah, you can see for each labels, decomposed signal, the actual signal which I showed, it was divided in the various components. And you can say that the input is these hours of the, you can say the input lag hours. Means for the S7, the first hour, 214 hours was used. Then you can say 157 hours before, to 113, that is 159 hours, 285, because 1 week before they were the data were taken. So you can say these are the data which are based on that previous, the correlation analysis were used. And based on the input of neural network, you can see it is a 20 inputs, the 19 various was again hit and trial. That's a number of layers was only taken 1, and the hidden layers was hidden neurons were taken 2, and our output is 1. So these two are basically used, the two AWN model and feed forward neural model. And based on that, I applied the techniques, trained them, and then I tested for the unknown signal, and based on that, output an error. Can you go ahead? So actually, this is not looking good, because I think 2 slides are coming on the top of that. It is a 2 models. Normally, how I can say my model is best? To know this, my model is best, the 2 normally models are available in the literature. We called it the persistent model, and it is a new reference model. From there, we normally test our models. And if we are improving based on those models, we can say, look, my model is best, and it is improving. And that's why these are the techniques. So go ahead. So this is testing only. So the various errors, normally we go for this. It is a RMSE error. It is a maximum absolute error or bias. Normally they are for the analysis purpose. That's my forecaster is good or bad. These are the error functions where we decide. Go ahead. Now you can see here based on that, and you can see the 30 hours means from here I'm forecasting for next 30 hours. Now you can say why 30 hours, sir, you are doing? It may be 24 hours, it can be 5 hours, or it can be mid hours only. 30 hours is required, especially if you are going for the electricity market. Because my market, I am going to bid at the evening of today, 4 p.m. And for the next day, 24 hours. So you can say 6 hours here and 24 hours going to be 30 hours. So based on that, normally 24 to 30 hours are required if you are going to play in the electricity market. And that's why 30 hours ahead. It's one time it is done. And now you can see it is going to be the actual is a black. And then you can say forecasted by the various like AWNN and FNN we have done. You can say this red is very closely matching with actual. But you can say there is a sharp is. No forecaster can capture that. And that is one of the big challenges. So that we can see, go ahead. The table will be showing, move, yeah. You can see this is a improvement over our error over the persistent model and the new reference models, how they are improving. You can say it is my error is no doubt it's reducing. Reducing once you are moving the look ahead hours, 30 hours. Beginning it was very less, now it is moving, but you can say still the forecaster is lower than which is existing with the persistent PER model or the new reference model. So it is an improvement over the existing one. Go ahead. Here also you can say it is the improvement is the more in the beginning and later is loss. It's just reverse of that one. So you can say it is a red one. You can say it is giving the better compared to that. The both new reference model as well as the PER model. So maximum absolute error is basically compared here. Go ahead.
It means that if we reduce the hour of prediction,
accuracy will increase.
Accuracy will increase.
Yes, of course. So, sir, right now, if I'm doing here, for the next hour. Very exactly, I can say what will be the temperature even though next hour. But if I'll say after 5 hours, what will be temperature will vary. So that's why what people say, they are keep on moving. That's why they one step ahead they forecast. Once time has come, then go for 1 hour. So they correct their model.
But now the trading is done for 45 minutes slot.
Yes.
15 minutes before and
50 every hour in hour 4 hours divided 4 times divided. 15 minutes. Yeah.
15 minutes. So that is possible with this model.
That's why I say 30 hours. Go back 30 hours. Why I have chosen that is the reason, because normally our trading is closed maybe at 6 p.m. So that 6 hours for the day, because and the 24 hours the next hour. So the 30 hours I have to forecast. So that's why I say the 30 hours I have to go. Normally it is a 30 hours, or some country it is a 24 hours. So that we are going. So you have to have that error, but you can say the error is reducing what is going to happen. But so here what we did earlier, it was the individual. I said means I used the AWNN model, the adaptive neural network model, and other I did the feed forward neural model. In this feed forward neural model, what I did, I changed slightly. You can see what I did. The wind forecast also I did at that particular hour. That forecast is input of FNN, and the past data is you can say, or your left hand side the data is coming power and the wind. So those are available with me, and then forecasted wind speed is coming to that, and then it is giving output wind power output. So this is improving further my output. This estimator, and it is giving the best output result, and then you can give the consider. Go ahead. You can see how it is matching. It is matching. You can say actual and the forecast is very close. Only the SAR pages, I just said, the SAR pages, it is very difficult. No estimator can pick up because it is you can say the outliers. Outliers means suddenly the wind speed has increased and the output has increased. But actually, it is following the trends. And that error is not very high, and that is basically manageable. This is, you can say, it is only the higher side, not even the lower side. Lower side, very small value is also there. So that is the giving error. Can you go ahead? So in the tabular form also I've given the result. So this is, you can say, the comparison with the various models. You can say it is calculated all this maximum absolute error and RMS errors that we have done. And improvement, you can say it is there with the persistent models as well as my other models in terms of percentage. So you can say the beginning it was a 5%, less than 5%, but it has increased to 25%. So that basically it is a very high value. If more and more wind is there, or renewable energy sources, that error is very, very high. If it is a penetration is less, 25% is nothing. Already I asked to my student, the maximum power transfer theorem. I say, where do you use it in the electrical system? We never use in the electrical system. Why? Because the 50% is lost. The efficiency is 50% maximum power transfer theorem. But electronics people use it because they are using in the milliwatt. If 1 milliwatt you are giving, and even though 0.5 is lost, no value. But if your 100 megawatt is flowing from a generator and coming 50 megawatt, just you can imagine what will happen to the system. So it is basically for us, if the penetration increasing, that error is very, very high. So we are trying. That's if you are going for 30 hours, it is a very, very erroneous. So it is better to go for the few hours, 5 hours, 6 hours. And that's why in the like UK, now it is only the 3.5 hours biddings are there. And 3.5 hours, you can say up to 5 hours, how accurate is less than 5%. And that is good enough. And that's basically needed. Even the load forecasting, what we do, that is also 5% to 2 to 5% is coming. So those are basically, it is the techniques, and we have to again further improvement. I'm saying it is not end of the life. It is still require the improvement, right? It is again, you can say the improvement. That's how it is going to another scenario. Go ahead. Now the similar we also did for the solar. The solar forecasting we did, and go ahead. So same model which I proposed there, we use for the PV system. We took one 375 kilowatt array which was used, and used it was the data is taken from NRL side USA, and it is basically the data of the 2008, 9, and 10. Why you can say 10? It is a 22 because this work we did in some, I think 2018 or so, or 16 or 17. So that's 14 or 15. So that data was available because these are the data, the standard models normally we take, so that you can compare with the existing data, and it is the smoothened data. because many data you will find they are having the outliers. There are sometimes certain other problems has happened. It is not related to the solar irradiance. It is due to the technical problem in the wind turbine, solar cell itself. So all the things were there. So they basically we collected the data, and based on that, it is basically we forecasted only for the 6 a.m. to 7 p.m. Here we know that once it is going to be evening, the output is going to be 0. So no need to forecast in the night. Only we have to forecast in the daytime, and now you can say it is only 11-hour forecasting. However, the wind you have to go for the night also. Wind is better even than the daytime. But here we know this 11-hour is sufficient for me, and only I have to forecast, so error will be further improved here. So the various analysis we did for the choosing the which hours data I have to the previous times data I have to take. For example, I'm going to forecast for the 11 points solar data I have forecast for the day. You can say that this hour data, then the previous 2 hours, then the 13th. You can say next day, same time. Next day, 1 hour before. So that previous days, as well as previous weeks or previous years, data will be useful for the forecasting of the other data. So that's autocorrelation analysis are done, and the various lags are calculated, and it was found these data are very impactful for the forecasting of the data, and based on that they are chosen, and based on that the forecasting is done. So go ahead. So here already a adaptive neural network. Only just I'll say why this neural network. It is nothing but it is a black box. It is just like a mapping. Here you are giving the input and output. This you have to have some weights are trained, and the input layers there is an activation function. In the normal neural network we use the sigmoid or tan functions. Here we are using the wavelets, that is the wavelengths, and that is a very exactly matching. So only the changing the activation value, it is this model. Model is same, and since I've used the activation function different than the conventional, it is known as the adaptive wavelet neural network, because the wavelets are having the two property. One is the translation and another is the dilation, and both we can trained properly so that you can very exactly map your forecasting, and that will giving the data. So based on that it is done. So we used basically the two AWNN is compared with the feed-forward neural network, and also we use the autoregressive model to compare our AWNN. Go ahead. So the 4 seasons were selected. You can say the March. Here you can see the dots. You can say the AWNN, it is closing to very close to the linear line. And you can say the feed-forward neural networks is the scatter, means more error. So it is a different way to represent the error. I want my all the data should be the linear one. One is the forecasted, one for actual. So that data, if it is on the line, means it is a very accurate, and if it is not on the line, it is a erroneous. So you can say the first bottom figure, you say it is a stick error, means the feed-forward neural network is giving error, and you can see here there are few are other than the linear line, means those are the error and maximum error are occurring at that time. Right? Similarly, I did for June. You can say June is more predictive, and you can say on top. This is the same thing is represented here with the forecasted value and actual value. So based on that, it is many ways to represent. One is sometimes people write in the percentage, some people write in the lower one, some people write the actual, that they can say all the 3 figures are there. Based on that, you can know. And you can say how it is matching. It is a very accurate in the forecast, right? December, you can say it's a very tricky everywhere. You know, it is a fog, it is a windy, it is a cloudy, and you can say the error also is showing how bad it is. December is a very difficult to forecast, because we don't know, even though nobody knows that it will be fogging or not. And you can say here, even though AWN model also, it is showing it is not on the straight line. It is a lot of, the data are here and there, forecasting errors are more. So that is you can say June is a completely clear sky days, and you can say very accurately it was modeled. But in the December, it is like this. Go ahead. So the digital technologies, this is the last slide. So already I take using this artificial neural networks or all these things, that is a very important, because we have to forecast the data, we have to correct the data, we have to smoothen the data. So the data analysis and data analytics and apply the soft computing for the forecasting of our renewable energy sources is a very important. So the accurate forecasting approach is required, which I discussed in that, but we require many other things already that are helping us in terms of cyber physical systems, like more data handling, how to handle. You know, everyone is having the Gmail. Just you can say how the Google is handling. Just everybody just be logging and suddenly my all mails are pop up. Just you can miss the millions and trillions people are on the Google. At least 1 or 2 mails everybody is having. So they are very good in the data. And I can tell you they have opened the electrical smart grid also in their office. Because once you are having the data, what you are going to do with the data, how your data mining you are doing, how you are digging the data, all these things are important. So that's why the data analytics is one of the very good concern. So utilization of demand response, we want the cost-effective information and communication technologies, integration of renewable energy sources, already we are doing in a very massive way. We basically have to operate my electricity market, and we are using more and power quality and other things because the power electronics we are adding. So these are things are also equally important in this one. And the digital technologies are going to play in all the corners, all the way. And that is one of the best approach, and that is there. So I'll go ahead. I'll stop here.